computing, every industry has a unique use case when it comes to edge computing, right? So we have people on the panel today from different industries. So I have my questions to them. You all also prepare your questions, so at the end of my session, that you can bombard them with those questions. Okay. So first, I would actually ask each of the panelists to give what is the edge computing use case in your industry and your current status in terms of how you're actually exploiting that.
Hi, I'm Manjunath. I represent TVS Mobility here. So as part of TVS Mobility, I had the infra and operations part in a TVS Mobility group. TVS Mobility as such, we are primarily into the dealership management and service management of automotives. In this segment where we are primarily into automobile servicing and sales and service, we use edge computing more in terms of our IoT devices. So IoT devices is a good use case for us to see how we can utilize the edge computing concept. Of course, we are taking the baby steps in that, and we are yet to go a long way in that.
Hi, this is Deepak, and I represent Royal Sundaram General Insurance. Royal Sundaram is one of the first private sector companies to be licensed. We've been in business for about 24 years. We're entering 25 years of existence next year. I handle tech, data and digital. As far as edge computing is concerned, yeah, we've done, I think the industry per se has done a lot of pilots. We've worked with various startups, data center companies, solving various use cases, but I don't think we have a full-fledged use case right now. I mean, there's a few things that I see in the motor insurance space, which is the OBD or telematics. My friend here is nodding. So that's, I think that's something that many companies have tried, but the OEMs have sort of usurped it. They've made it their own space. So that's one area. Smart watches for monitoring vital statistics of health, etc. That's another use case that I can imagine. Yeah, long and the short of it is there are lots of use cases, but still very exploratory, Suresh.
Okay.
Hi, this is Pragati Kumar. I work for Orchid Pharma. We are a pharma manufacturing company of 30 years old, and we do produce for the API and the formulation medicines. So I would be sharing the edge computing, the importance of the edge computing in the manufacturing pharma industries. Can I know, like, what is the crowd for pharma industry, manufacturing pharma? Can you raise the hands? Only 1, 2, 3. Okay, anybody from specifically for API pharma manufacturing? No. Anyway, so it will be Greek and Latin for other people, but you have to take it as a knowledge related to pharma manufacturing, because pharma is something which is very attached to everyone. We all take medicine, so it all gets manufactured in our plants. So it would be nice to know how the decisions are taken in the edge computing in the pharma industry. Thank you.
Hello, good afternoon. I am Balaji Sankaranarayanan, representing Equitas Small Finance Bank. As a banking industry, the banking and financial industry, there's a lot of tech-related implementations has given a lot of significant benefits to the customers and the banking industry as well. So when we talk about edge computing, specific use cases are where the video KYC, where we have the real-time facial recognition while onboarding or authenticating the customer is one such, we could say, and the image processing when we wanted to process the documents. These are two use cases where the industry has seen. There are other use cases, I think it's in a very primitive stage, like monitoring the health as not directly related to the banking industry, but as a targeting elite customers as an offering is something that the industry is looking at.
Okay. So I can understand that each industry has its unique requirement, as well as they are in different stages of adopting edge as a technology. So Deepak, to you. So in case you want to approach using this edge technology within the organization, how would you actually approach? What should be the sequence in terms of arriving at a final decision whether edge is useful for us and what we should be actually using it for?
Yeah, it's a good question. Sometimes we get carried over by technology, and for the right reasons, there's very good tech out there, but we need to be able to marry the tech to the right use case.
Correct.
So, let me just dumb it down for you. So, let's say we take a look at the insurance business. In the insurance business, motor vehicle, people take insurance because it's also a mandatory thing. It's mandated by law. When you drive a vehicle on the road, you need to have third-party liability. In India, like in the West, we have the concept called as knock for knock. So you're driving on the streets, you're driving in your car, you knock another car down. There's in the insurance world, there's something called as knock for knock. So the two of you claim damages from your respective insurance companies, and if it is a bona fide, genuine claim, then the insurance company pays the claim, then settles the case, and everybody goes home happily. In the case of a third-party insurance, it's a little more complicated. There is a motor tribunal. You got to go fight the case. There's the legal system. There's the courts come into play. There's assessments and so forth. So there's a little more long drawn. And then the actuaries, the actual actuaries, carry that risk in the book for about 15 years, and they make the data forecasts. So short point is getting the use case right is of paramount importance. So if I'm doing motor insurance using edge, let's say what is known as telematics, which is a simple computing device and there's an OBD port in every car. And it's a 10-15-year-old story. The OBD port is what is used for diagnostics. Whenever you drive your car into a garage, you have the car mechanic that just plugs in a device into the OBD port, and then you have all the vehicle statistics that's coming out of it for preventive maintenance and so forth. So that's predominantly the use case. So what is the device? How does that device connect into a motor vehicle? How is it processing data? And how is it transmitting that data back to, let's say, an OEM and then back to the insurance company to be able to make sense of that data and underwrite? So largely, use case is very critical, because for us in the case of an insurance company, we will get to know, let's say, the driver behavior. We'll get to know the vehicle, health of the vehicle. If the vehicle is involved in an accident, we'll know exactly the details of the accident. We'll know the characteristics of the driver, how well the driver, he or she is driving, what's the acceleration, deceleration, how is the braking, how does one take the curve on the highway, are they adhering to speed limits? So these are all driver-based, usage-based insurance, what they call as UBI, which is predominantly riding on the characteristics of the driver driving the car. So from an insurance perspective, the OBD device, there's a manufacturer, and there used to be a point in time where you had, the manufacturer's OBDs were very, very sparse, but today the technology has also improved. So you get really accurate data. And what do? We can only, if we get to know these parameters, we'll be able to offer much better discounts to consumers. Okay. So that use case from the consumer perspective, can I get cheaper insurance? Okay. Because there is anti-selection, right? I know how I drive the car, but the insurance companies does not know my behavior, right? So there's automatically this anti-selection that gets included. So use case, like I said, I keep repeating, that's number one in the decision-making tree. Second, technical feasibility. So these OBD ports are transmitting a lot of data. So ability to collect data, process data, store data, transmit data, and typically what's called as an M2M chip that is communicating to the tower. Tower is relaying back data to the OEM, because the OEM is the owner of the consumer data in some sense. And then the OEM transmits that data back to insurance companies. So that's the second bit, which is the technical aspect of it. The choice of the OBD device that we are selecting, the underlying operating system, latency requirement, which is another big thing. Because in the case of telematics, you need data in a low latency fashion, right? You need data to be available to you in a real-time basis so you can make sense of it and make better underwriting decision. And of course, I think the previous panelists also spoke about network. expandability of the network, speed with which the data gets transmitted. So in my in the way I look at it is these three things in terms of the hierarchy of decision making: use case, technical feasibility, and ability to transmit data back.
I think I will use that information to question Manju subsequently. So how difficult it is, Manju, that to implement all those things at the vehicle level, because now, in fact, the previous panel spoke about AI at the edge. So now we'll start with the basic telematics information gathering at the edge and getting it back to the back end to make it an useful information for a use case like insurance. How difficult it is to actually do that?
Well, Deepak has explained very well about my use case study, which is exactly we go through the pain, what we do, the implementation of the OBD devices, data collection, all. The pain area really comes where the getting the data in the real time. That is one. And the second thing is on the latency part, what we feel when pulling up the data or giving it back. Then the third thing is now, since we see that, that's where the edge computing comes into play, telling that the data that is getting stored in the local SIM or whatever the capability is there, can that be enhanced, and there can be some intelligence built in there to take some decisions rather than getting into the cloud, processing it and then sending it back.
Okay.
So those are the pain areas what we see today. But if you say, do we have any ready solution today? No is the answer, because that's still in the development stage. Every company is learning now by implementing it. And as everybody knows, AI doesn't come overnight. It takes some time to build over it and refine it, retune it and all. So the pain area what I say is today is the latency, the storage part, and the speed of data transmission that happens. Because even now, though the whole country is talking about 4G and 5G, there are still few places it has to cover up. Okay. So there definitely, when the vehicle is moving in that segment of the road, we see the sudden loss of data, and suddenly we see some tampering happening. So there are many challenges what we see in the implementation, but still we are making a good progress in that case.
Okay. And I will take the same question I gave to Deepak to you, Pragati, in terms of how would be you identify the use cases in your specific industry where edge is appropriate, and how would you proceed with that?
Okay, thank you for the question. Just I would like to take a little bit of basement to set right, because not except 2 or 3 people from pharma industry. So if we talk about pharma industry, majorly it is a 4 vertical session. One is a API, which is a raw material for making a medicine. Second vertical is a formulation. So for formulation, the API is the raw material, and formulation is the last product which we all intake or inject to the bodies. And when you talk about research, there is again 2 sub-vertical inside the research. One is called process research. One is a new molecular or new drug research. So when you talk about the manufacturing, these are the 4 major verticals comes into the picture. And when we are talking about the subject of edge computing, the edge computing plays a major role in the API manufacturing and in the formulation manufacturing. Most likely, most of the quality process is automated through the edge computing. So if the edge computer is not able to take a right decision in the manufacturing process to find out the quality of the product as per the requirement or as per the manufacturing practice, then we all will be taking a wrong product. Okay, and there are quite a lot of parameters which we have to measure to give a approved medicine to the end users, and those decisions are taken in the edge computing. So there are a lot of processes are involved when we are selecting a edge computing or the decision-making computer in the manufacturing area, which might be, I will be sharing going forward, like what are the sessions. But this edge computer is the last person to say whether the product is yes to go to the consumer or not, specifically in the formulation division. Okay. When we are talking about the API, that is manufacturing of the raw material for formulation division, so there edge computing plays a major role again, which monitors the complete process of the reactions of the chemicals and giving the input to the software, which takes again a decision what's the next process and when to start the next process and how to control the next process. Nowadays only we are talking about ML, AI, Gen AI, all the things. But these all are conditional based available in the pharma manufacturing for a long time. Because we are a 30 years old manufacturer company. Yes, earlier it used to be a conditional based. Now we say those conditional are built, matured enough to make it as a AI and, you know, some of the decisions which employees or the person used to take, now those things are getting little automated using the AI. But still, though we are in the Gen X world, but still we are not 100% dependent on AI, neither we are accepting the 100% AI. Because if there is a 0.00001% of mistake, we are playing with the life of the people. So we cannot take that risk. But yes, we take the input as an input for the person to get ready and take a next decision. For that purpose, we use those AI. Otherwise, we are still a people-oriented,
You are still
people
man in
process.
the loop approach.
Yes.
Right. Yeah, and to you, Balaji, actually in your you mentioned about implementing edge at the layer where you actually do your KYC process, right? So what were the difficulties when you actually started to adopt that?
Deploying and using edge computing comes with its own challenges, primarily due to the complexity of the devices at the less secured environment, and also novelty of the technology. It's only evolving, so the much more tools, processes, standards are expected. It's on the way. So network and connectivity is major challenge that we see, because we work on a real-time basis. So when we onboard a customer, and it's through a video call, video KYC, it's a video call, which means that the connectivity has to be real-time for me to validate, so that the customer is alive and I'm talking to the right customer, and within given seconds, I have to ask specific questions so that he answers. So that makes it easy for me to onboard and authenticate that I'm dealing with the right customer. So inconsistent or unreliable network actually impacts my real-time operations. So latency and bandwidth, these are two things that we need to look at. These are challenges that we see, and it needs to be, like Deepak mentioned, we have to identify a specific use case and then ensure that we see some benefit, significant benefit. Apart from that, now that we have GDPR globally and the PDP coming in place, the edge devices creates data silos, which means that the data is getting stored locally, and and it is also getting processed and stored locally, which gives a lot of room for data privacy issues. And since we are from the banking industry, we are governed by the regulatory authority. So we have to ensure that we comply to the regulatory authority and the customer data, the PII data in place. Apart from that, there is vulnerability and physical tampering of those devices. So these are challenges which we need to ensure that these are covered before we get into production.
Okay. So coming back to you, Manju, what do you think are the critical success factors for a successful edge adoption?
Well, for the critical success factor, every size doesn't fit one. So it depends on the use case from company to company and from vertical to vertical. In case of, though the technology is available for all the verticals, we have to really see if it is really relevant to us. Is it going to give me the ROI for that? Is it going to be beneficial for the growth of the business? So not only that, being from automobile industry, everything goes from the cost consciousness. So though there's a lot of technologies available, though everything is available, reliable and usable, we have to really look at the use case which is relevant to me and to my business organization growth. If we look at these two things, then we can prioritize on what is that we can use. Though there are a lot of technology, only this particular segment or one or two segments will fit in my business case. So we have to take that, and once you take that, my suggestion would be don't go for a big bang approach. Try it, see if it's really applicable to use it to your vertical, and then go for it. So this would be my suggestion based on our experience, what we have seen. Though all technologies are available, see if it fits your organization, if it fits your bill, and then try it and then go for a big bang. That would be my suggestion, is what I say from here.
Okay. So in your industry, what do you think would be a critical success factor, Deepak?
So I think, like Manjunath mentioned, I think the tech is reliable, right? So you take Fitbit, like I'm wearing a Fitbit here. I don't know why I took the brand name, but yeah, I'm wearing a Fitbit. But any smartwatch for that matter, it's able to basically measure accurately the temperature of your skin, your oxygen saturation, your resting heart rate, your blood pressure. All these parameters are needed from an insurance perspective. These are very good set of parameters to be able to, let's say, underwrite a life, right? Most insurance companies will look at life that is risk-free, right? A single person, somebody is like lesser than 30 years of age, relatively disease-free, no pre-existing, couples, double income, no kids, what we call as DINK. So are good quality lives to have. But, I can't, but insurance is for all, right? Yeah. We'll have to offer insurance to every person that, and there's a risk to that life. So therefore, we can't selectively offer and not offer to somebody else. So one critical success factor is these devices, the ability for it to capture data and good data, and be able to communicate that back to either a service provider, a hospital, a clinic, or an insurance company, or let's say the government. That's critical. Second is, what do we do with this data, right? Can I reliably and responsibly use this data to either quantify a risk or qualify a risk and make that affordable to the end consumer? Third is ability to work with a good service provider who understands the industry that we represent. See, we are buyers of tech, right? People on the other side of the table, they know how to run tech better than us. We run tech within the industry. So we know what choices of tech that we need to make to be able to solve a specific problem in the industry. So there has to be a good, heart to heart to, make that match happen. So I would say a service provider who understands, like Balaji mentioned, he talked about, a reliability of the network, bustability of speeds that are necessary to run the business. These are very critical, factors. Your service provider that you choose need to be able to understand the problem that your consumers, they face, right? So that's what I think are critical success factors.
So what I actually gather from these discussions is data privacy is important when we talk about collecting data at the edge, and latencies and reliability of the transmitting medium in the middle, so that that data comes back to the backend processing accurately. So this is a data center convention, right? So this question I throw to all the four of you. From an edge computing standpoint, so what do you think that data center providers have to actually do properly so that the difficulties that you are facing can actually be solved, or a solution that is there for the difficulties that you are facing?
Let me take the cue on that. Well, the help, what we can look for from the data center operations is the reducing the latency part and how they can build the POP centers, how they can connect me to the main center, because the main center sits only in one place, so you cannot expect to have POPs at all places. Yeah. So what is the solution that data center of service providers can offer in terms of having a proper edge so that my vehicle travels all across the place? So how easy is it to transmit the data and process it? That would be the one help. The dynamic storage capacities, the dynamic expansions, the flexibility what they give to ramp up and ramp down, that would be the another key requirement that we can expect. And the third thing is, as I said about the latency part, how can they drop the latency perspective to build that real-time data transmission? This is what I can expect.
So in the insurance business, to make a very pertinent or specific point, so IRDA has this vision of by 2047 insurance for all. So we were in a briefing session with the IRDA chairman. Very clear vision. It's laid out on in stone. There is participation expected from the insurance sector. There's participation expected from hospitals, third-party administrators, etc. The regulator has also come up with what's called as the rural obligation, rural insurance obligation. So we've been allowed. So every insurance company is allotted 2 districts, one large district, one small district, and the Gram Panchayat, which is actually allocated to the insurance companies to go and penetrate, because the insurance penetration in India is still less than 2%. If you take a vote across this group, I can sell insurance to 99% of this audience. Because everybody will be underinsured. You take the panel only, I'm pretty sure that 3/4 of the panel will be underinsured, right? So this is it's an awareness problem, and it's the issue has been plaguing the industry for quite some time now. Now, what the government wants to do is they want the insurance companies to go and penetrate insurance at the Gram Panchayat level. So they've mapped the pin codes to Gram Panchayats, they've mapped the Gram Panchayats to the districts, they mapped the districts to the states, and every insurance company has been given 2 states to go and operate, right? So there is a scheme from the government was what called as the Bima Trinity. So you have the Bima Vistar, which is the composite product. How do I do CKYC? Like, I can't do that unless there is last mile connectivity that is very important, right? So I'm hoping that the data center guys, it's in their hands and they seem to have solved it reasonably well. And I'm very confident that this is going to happen.
Yeah. Lots of business opportunities being thrown out for the data center people. Yeah.
Okay.
Yeah.
When we are talking about pharma related, where these data centers can help, it's most about the storing and archiving the data. Okay. Though edge computers are taking the decision and all, there is a lot of machine data and the production reaction data. It all comes from the SCADA systems and all, which comes to the edge computing. So as per the regulatory requirement, the minimum years to store the data is 15 years. So every, I would say, week or maybe 3 days, we are generating more than a terabyte of data. And these data have to be kept for 15 years, which is minimum trend. And more than 15 years is a business requirement again. What I mean of business requirement is we may need to analyze the data for improving our process. Okay. So process-related data, machine-related data, how the machine is reacting. So those data and all have to be retained. So till today, we have around 25 years of complete data which is maintained. Though regulatory says 15 years, some few regulatory says 25 years. But so where we need the assistance is properly maintaining and keeping the data and giving the archival options, and should be easily accessible through our AI-based applications, which will give the output or analysis of the new process to find the findings. So as they said rightly, like accessibility and the bandwidth for doing the proper backup, and which is a continuous backup, because we are into completely continuous process industry, where the machine will be keep running, application will be keep collecting data. In the back end, the backup also should keep running, so that the clearance, new data, that cycle is running. Even though now we have the computers with 1 terabyte, 2 terabyte hard drives and all, but still that is not enough for a week running also. So accessibility, connectivity, and capacity, faster access, faster write, These are all the minimum requirements for us to select the data centers.
Okay. In your case.
See, I see that edge computing itself is an evolving industry in itself, because the application part is going to be disrupting most of the industries. So I'll just pick up a couple of use cases where you take a windmill. When as a banker, if we have to fund say 30 crores, 40 crores and building a windmill, and also the windmill needs to be insured. So there comes the insurance partner in place. So if we have the edge computing devices like IoT sensors or IoT devices in place, we would know it will help us to cover the insurance windmill somewhere in Ramanathapuram, Ramnath district, or up north, northern Tamil Nadu. The wind pattern is not going to be the same, and the power generation is not going to be the same. The impact of natural calamities will be different. So these sensors will collect this data and send it to the central systems, and that is where the the data center comes in place, where it has to collect huge amount of data. As the industry evolves, the amount of data that we are going to collect and process centrally, though it will be processed at initial level at the edge devices, most of the data will get processed at the central system for analytical purpose as well. So we need to have a hybrid system where we will be dependent on data center and cloud services to manage the load processing. I see that the need for data center and the growth in data center for storage and processing, more GPU and CPUs are required. That's what I foresee. So more number of building racks or data center or farms is needed.
Okay. How much more time we have? No questions? Yeah, couple of questions. So the word couple means it can be from two to anything. Yeah. Yes, please.
Company or your company?
No, see, I just picked up a use case which, because we study various use cases, and in India I have not come across, but this is a use case that we have taken in US. So it depends on where you put your equipment. So it has to be always at the source. So who owns these sensors, devices? It will be the windmill, either the person who owns the windmill.
You see it only being, I mean, I understand the use cases, but in terms of
Can you just repeat the question? Sorry.
so just a high-level question. So I understood the use cases we talked about, but the notion of calling it an edge, do you think it only is relevant for large countries like India? Or what about European countries where even the main regional data centers may be able to deliver the required latency because the countries are smaller in size?
I think, can I answer that question? Because see, the concept of edge is not only about sending data back to the nearest data center. It might be a requirement where data is processed locally at the place it is generated, and only derived data is sent back. So in the case of windmills, when you want to actually process the data to tell the windmill do this or don't do this, that processing capability has to be within the windmill itself. So edge as a requirement will be there globally anywhere. Wherever local decision needs to be taken based on sensor data, you need a processing capability locally.
So I'll add to what Suresh has mentioned. So a typical case where when it is a windmill, you have sensors. The moment the sensors identify that the wind force is much higher, the sensors will send out the signals to the windmill, which is part of the windmill, and it will shut down its operations, and the wings will come down. So that will save the capital investments of the entire windmill. So not necessarily, every decision has to be sent to the central system and then get, instructions from there. There are certain things where quickly we may have to, suddenly a turn in directions of windmill will twist and, break down the entire windmill structure. So these are things where a quick decision needs to be taken, momentary decisions where the edge devices will help or the sensors will help. I hope I answered your question.
Rahul Makhija, Astro Networks. Actually, I wanted to ask this question for quite some time, and thanks to W.Media, I got a chance now. Thank you. So I see latency and bandwidth have been mentioned quite a few times in this discussion, and there are internet exchanges to target this specific issue, and Government of India have been operating one since like 2 decades, almost 20 plus years now. That's in National Internet Exchange of India. And the question is, in the Western world specifically, I see most of the corporates and large enterprises, they participate in those internet exchanges. While in India, they're like I hardly see any of the corporates participating in any of the internet exchanges. So I wanted to ask if there is any specific reason, or is it just lack of information? So,
I take it as purely lack of information and the awareness spread what we have, because now and in India I see a lot of initiative steps being taken when compared to the Western world. So in that case, I would treat that as a awareness information.
Okay.
Okay, so thank you, gentlemen, for being on this panel today, and I learned a lot about edge use cases, because that's a concept which is very close to my heart. Thank you so much, and thanks W.Media for having us today.